Okay, I think we're all set. Okay, so what did we talk about last time? Yeah, I have no memory. Oh yeah, we finished up talking about some basic ActiveRecord stuff, didn't we? Validations, that's what we were doing, validations. So we finished up talking about validations. We talked about the last couple built-in types. We talked about building custom validations. And then we talked a bit about migrations, right? Yeah, I think that's where we were. So what we're ready to start with today is some of the extra stuff. I don't know, it's fair to call it extra stuff. More advanced features of ActiveRecord, right? Starting off with these things called callbacks. Right? You might have noticed that there's obviously sort of a series of steps that ActiveRecord goes through automatically when we're actually working with ActiveRecord models. For example, the validations. When we create an ActiveRecord model and we save, we never specifically had to tell it validate. Right? The ActiveRecord setup simply knows that if there are validations that we have specified to be performed, that it should perform those automatically. Right? So there's a series of steps that ActiveRecord basically goes through at certain times under certain conditions. A certain set of steps ActiveRecord automatically goes through whenever we create a record, whenever we try to save a record, whenever we try to update a record, whenever we destroy a record. Right? There are built-in steps that ActiveRecord always takes anytime we go through any of those things. The automatic application of the validations that we've been talking about is one of those things that happens automatically when we create, update, or save, for example. Right? Those steps that ActiveRecord automatically goes through whenever we do any of this different work with ActiveRecord models is something that we actually have the ability to tap into, and that's what these callbacks are. Callbacks are basically methods that we can call from inside the model, right? So we could pull up a model file, like our book file, for example. And inside there, what we could do is we could use a variety of different methods to specify particular actions that we want to take place during the course of actions that ActiveRecord takes when it's going through and creating or saving or destroying or updating a model. Right? Easiest way probably to explain this is to go ahead and demonstrate it. So what I want to do is I want to start a new Rails app here. So I'm going to make a new Rails app here on my desktop. I'm going to call it Tutorials Example. Basically, what I want to do is put together a model, something like the steps of a tutorial. If we assume that a tutorial will teach you how to do something, and in teaching you how to do something, it'll take you through numerous steps. What's my message I got here? Doesn't look like any big deal. Okay, so a tutorial we'll say is a series of steps, right? And we could say that steps are something that always occur in a particular order, right? So let me dig into this and I'll show you kind of how callbacks could potentially come in handy for us here. Right? Here in my new model, let me go ahead and, or here in my new application, let me go ahead and generate a new model. Right? I'm going to say this is a model for a step, one particular step in a tutorial. And I'm going to say that every step has a position, which is an integer. I'll say that every step has a title, which is a string. And every step has a body, which I'll say is text. Right? Now, the title of the step, basically what this step is going to teach you how to do. The body of the step, which would be the actual instructions telling you how to do that particular step in the process, are both hopefully pretty self-explanatory. The position part would be how we would keep track of what order the steps go in. You might imagine that we might want to set this up so that in the future additional steps could maybe be inserted between steps that already exist, or maybe steps could be rearranged, could be reordered, right? So I'm putting that integer position column in my step model so that we'll have some mutable, some flexible way of being able to keep track of what order the actual steps are supposed to go in. Once I generate that model, that of course makes my migration for me as well as the model file. Okay. I'm going to go ahead and do rake db migrate to apply it to the database. So I should have my step table at that point. And let me go ahead and pull it up in TextMate. If I go over to my model file for step,
What rate would you do again? Rate
db:/migrate. We could go ahead and do any validations that we want to do. Right? Maybe I'll say validates the title for presence. So we can't leave the title true. I could put in the other validations, of course, if I wanted to check and make sure the position was numeric, if I wanted to check to make sure that the body wasn't blank, all of those sorts of things. I'm not going to mess with it too much. I'm just going to put in a validation for the title right now. When we're playing with this thing out in the console, it'll be more convenient if I don't have to fill out a complete record every time. Okay? But at this point, what we could do is we could actually start playing with the model a little bit. Okay? If I jump over to my terminal, start up my console, I don't have awesome print and HIRB in my gem file, so I got my little error messages there. I think I might actually want them, so let me real quickly jump back out of the console. Back over in TextMate, I'm going to open up my gem file. And in my gem file, I'm going to put in a development group. And I'm going to tell it I want gem HIRB and gem awesome print. Is it underscore? Yeah. There we go. Add that to my gem file. Back over on the console then, I'm just going to run bundle, which will make sure all the gems that I specified in my gem file are installed, all their dependencies are there, and everything's ready to go. Then if I pull up my console again, we have HIRB, we have awesome print, so we'll get to see all the pretty output goodness from those two as we play here. Okay? So let's say I wanted to create a new step. I wanted to put in a new step. Okay? I could do step.create, for example. I could say that the title is step 1. I could put in whatever body I want. I could put in whatever position I want. Maybe I'll go ahead and say the position is 1. This is supposed to be the first step. I hit enter. That new record is inserted into my database, and I've got my first step. I could do that again, specifying position or the title of step 2, and I'll say this one goes into position 2, and now I have 2 records out there. If I say step.all, I can see the 2 steps that I've created. Overall, that's pretty okay. Right? But the part where we're setting the position is a little bit more manual than I might prefer it to be. Right? Imagine that I created a 15-step tutorial. So I've got 15 steps already stored for the tutorial. And a few months goes by and I realize I want to add another step to the end. Well, what would have to happen is I would have to first go see what the position number of the last step was before I could add the new step at the end, so that I would know what to set position to. Wouldn't it be a whole lot more convenient, right, if we, working on the assumption that steps are normally going to be entered in order, if we could, for example, have each step when it's created automatically set its own position based on whatever the last previous position was? Now, position, of course, at that point would still be something we could change in the future if we wanted to, right? But it would be a little bit of an advantage if we could just have the steps basically sort of default to automatically assigning their own position so that they automatically become the next step in the tutorial without us specifically always having to tell it, you are step 1, you are step 2. You with me? Make sense? Yeah. If we wanted to do something like that, we could, over in our model, add some method basically to set a position, for example, where we could create a new step and then we could call the set position method on it. And in the set position method, we could essentially have it look up what the last step saved was and then automatically make its own position the next number. Right? But that would still be a manual process. That would mean that we would have to create a step, then we would have to call set position on it. Right? Then we could go ahead and save it once the position was set. That's not a whole lot better than just typing in the position myself. It is slightly better because at least it would figure out what the next position should be. But I would really still like for the whole thing to be a little bit more automatic than that. And that is where these things called callbacks could potentially come in. What I can do is I can tap into the process that ActiveRecord goes through when we create new records, when we save records, when we delete records, when we validate records, when we update records, any of those different things that we typically do with a record, we can tap into the process that ActiveRecord goes through while that process is in works, and we can give it extra things to do. So for example, here I could say, before you save a record, set its position. That way, when I create a new step in my tutorial, I could simply say, here's the text, or here's the title, here's the body, and then I could just say save, and as part of the save process, it would know that it's automatically supposed to set the position. Right? So the way I would do that with a callback is Rails gives me a method called before save, which I can't type, before save, that I can put in there and make use of. Basically the way it works is I would call the before save method, and then as a symbol I would tell it what method I want it to call. So I tell it, before you save an object of this model, basically before you save a step, call the setPosition method. There are a lot of these callbacks that are available. I think that's the one that I want to use here. But some of the others that are available, there's before create, there's around create, there's after create. So in the create process, basically when we call the create method, which is both instantiate a new object and save, we can tap specifically into those three different parts. The around create is kind of an interesting one. Before create obviously happens before something is created, after create after it's created, but around create, what you can actually do if you do an around create callback is you can write a method, and then somewhere in the middle of that method you can yield, call the yield method, like you do with blocks. What ActiveRecord will then do is it will execute the beginning of the around create method up to the yield. Then, when you get to the yield, it'll go ahead and do its normal create stuff, instantiate the object, save it to the database. And then when it's done, it'll come back and it'll execute the rest of the method that comes after the yield. So if we wanted to log every time a new object was created, we could put a starting log message, then yield, then an ending log message. So we would know exactly when the creation of the object started, exactly when it ended, things like that. Right? So the create we can tap into. Right? We can also tap into the save process. There's before save, which is the one that I'm going to use. There's also after save. So we can have something execute automatically before or after a model is saved. Right? There is the same ones for update that there are for create. So we can do before update, around update, or after update. Right. For destroy, we can do before destroy, or after destroy. And we can tap into the validation process. We can say before validate, validation, and after validation. All of those callbacks are available. So anytime there's a specific action that we always want to happen at any of those individual points in time, these callbacks can be used to automatically trigger that action. Nice and convenient. Do you have questions about any of those? When they would happen? Just please don't ask me to dream up of a scenario for using every single one of them.
Does around get used a lot?
I can't think that I've ever seen it be used. I haven't really been looking, but I know I've never personally run into a situation in the real world to use it. Okay. Mostly before and after save, it seems like, are the real workhorses to me. I use those a lot. Okay. All right, so here with our step, the basic idea was every time we go to save a new step before it's actually saved, we want it to call the setPosition method. Okay? To get the setPosition method to actually save, or to actually generate a position for the new model, okay, what I would need to do is I would need to figure out what the last previous position was. So I think I'm going to create another method in here. I'm going to make it a class method. I'm going to call it last used position. So for the step class, I'll be able to call last used position and have it tell me what the last position is. And I think what I'll do is I'm going to say go through, put all the steps into order by position, and give me the last one. If I order all the steps based on their position, which would just be numerically lowest to highest, ascending order, okay, and I grab the last step, that last step's position should be the last position that was used, right? Okay. There is a little twist in there, and that is, what if somehow we've created a step that has no position, left position blank, right? Or what if there are no steps at all? What happens when we create the very first step? This will basically end up being null, or nil, sorry. Okay. Teaching 2 PHP classes and 1 Rails class, so my brain is defaulting to null, not nil. Okay. So anyway, if that happens, I guess I could do something like say, if we actually do have something for last, essentially if last is not nil, and that last item actually does have a position, right, then let's return that position. If either of those aren't true, then let's just return 0, saying that 0 will basically be the number we start with. So if we don't already have a position, or the position we have doesn't, or the step we have doesn't have its own position, we'll just default to 0. Might just go try that out. If I jump back over to the console and reload, if I do step last used position, it comes back and it tells me 2, which is currently correct, right? Right. If I do step.find the thing that has an ID of 1 and destroy it, actually let's get rid of the second one. And let me spell destroy right. There we go. I only have one step left now, step number 1. If I do step dot last used position, it tells me 1. That's correct. If I pull up that step, there we go, save it in a variable s, and then I do s.position equals nil, s.save. Now I have one step that has no position, and if I try my last used position method, it gives me 0, which is the default value that we were supposed to get if we couldn't retrieve a good position. And if I do step.find position 1 and destroy it, so that I then have no steps at all, if I call step last used position, it gives me 0. So it looks like in all the cases I can think of, it's returning a proper value. So I think last used position is working correctly. In my setPosition method then, what I was thinking we could do is we could use that last used position method plus 1 to basically set the position of something new that's being created. So inside this method I could say self.position will equal step.last used position plus 1, right? So every time a new step is created, before we save it, it'll call setPosition on it. SetPosition will call last used position to find out what the next number in sequence should be. It'll take that number, add 1 to it to get the next one. The one problem I can think of with this set position method is what happens if I already have a step already exists, a step already has a position, and I make a change to that step and then save it again. What this would do is it would wipe out the step or the position that the step already has in favor of a new one. Right? So right now it does it indiscriminately. Or if I created a step and I manually specified the position for it, this would basically override whatever value I had put in manually. Right? So really what I want is I only want this to happen if the position would otherwise be nil. So assign a step assign a position automatically essentially if self.position is nil. So if I don't specify one or if there isn't already one, then go ahead and assign one. Okay. So let me see how that works. Over in the console, if I reload, if I create a new step, I'm going to say the title is first step. I hit enter. Look at what was created there. Position has a value of 1 without me having to tell it. See it? Okay. If I go to create another step, second step, that one automatically got a position of 2. Okay. If I create one more, third step, that one got a position of 3. If I take a look at all my steps, they're numbered off nice and neat, 1, 2, 3. So if I'm creating my steps in order, which probably is what I would do most of the time, I've written a number of tutorials and I can pretty much guarantee that my normal way of working is not writing them backwards from the end to the beginning. It's usually going through them in order, step by step. Right? This would basically take care of the positioning for me. Wouldn't have to mess with it. Position, though, is still flexible. If I go back and change the position of one of the steps, that position should be honored. Right? If I say s equals step.find step with the ID of 4, which is the second step, so I have s, which is the second step. If I say s.position equals 12, s.save, if I take a look at my steps now, step 4 has position 12. And if I add another step now, what number should it get? Should get 13. Yep. Always one after the last one. So there we go. Easy enough. Pretty much all those callbacks work in the same way. Right? We used before save, but there are all those others available. So whenever something needs to happen automatically at any of those particular points in time, any of those particular points in the process, Rails makes it real easy to allow those things to happen. It's kind of automated in a way. Pretty smart. Okay. If you don't have any questions, we could move on. Next thing we want to talk about is really meaty, really good, important core subject, and that is associations. Right? Hopefully you remember associations pretty well from database work that you've done before, from database design, from a PHP class, anywhere you've used databases before. you've most likely used relational databases, and definitely one of the best and most interesting parts of relational databases is the fact that you can have these relationships between tables. I don't know what somebody else would say, but I've always thought of relationships in relational databases as being the thing that really makes them worthwhile. If it wasn't for relationships, being able to relate one record in one table to another or multiple records in another table, then really all you're doing is you're working with spreadsheets. That's really all you've got. You might as well just have flat files. Okay? But that ability to be able to have relationships between multiple tables makes relational databases really interesting. Okay? You remember how those things work? Okay. Made a little diagram for you. Right? Different types of relationships are possible. One-to-one relationships, one-to-many relationships, many-to-many relationships. Right? With one-to-one relationships, like the relationship maybe we'd have between an employee and an office. Right? If we assume that an employee only has one office and each office is only the office for one employee at a time, then we would fundamentally have a one-to-one relationship there. The employee table would be used for storing all the information about the employee. The office table would be used for storing all the information about the office. Right? It would not make sense or be good in a data integrity sort of way to have information about the office stored with the employee or to have the employee's information stored with the office. So having those two things in separate tables would be important, right, to avoid data duplication and all kinds of other problems. But still, right, there is definitely a relationship between an employee and their office that we might need to model in the database. Right? In this case, it would be a one-to-one relationship. Do you remember how we would actually construct that in a database? Well, every record in both of those two tables, essentially every individual employee and every individual office would have an ID number, right? The ID numbers would be unique, never two entities that had the same ID, so never two employees with the same ID, never two offices with the same ID, right? So that would then be the table's primary key, the thing that we can, in an undisputed way, use to identify one individual instance of one of those entities, to identify an employee or an office. If we wanted to then show a relationship between an employee and an office, what we would do is we would take, say, the employee's ID number, and we would copy it over to the office's table, where the office's table would have to have a field where that data could be stored. So, for example, the employee's table maybe would have a field called ID, which would be the employee's ID. Over in the office's table, there would be an ID field, which would be the office's ID. But in the office's table, we would also then put in a field called something like employee ID, where we would copy the ID from the employee table over to the office's table, and that's how the relationship would be formed. So whenever we, for example, wanted to look at an office, right, we could pull up that particular office's record, and as part of that office's record, there would be the ID number of an employee. We could take that ID number for the employee, use it in the employee's table, and then we would know everything we needed to know about the employee who works in that office, right? Is this all familiar? Okay. So one-to-one relationships, right? With one-to-one relationships, you might remember it's not particularly important where the foreign key goes. It doesn't really matter whether we put a foreign employee ID in the office's table or if we put a foreign office's ID over in the employee table. It can go either way when we've got a one-to-one relationship. Right? With one-to-many relationships, of course, the idea is basically the same, but where the foreign key actually goes makes a difference. Right? In the case of a one-to-many relationship, we always have to put the foreign key on the many side of the relationship. So, for example, the relationship between a tutorial and the steps, like we were just playing with. A single tutorial can have many steps. Each step, though, is a step in one particular tutorial. Right? Everything has their IDs, and what we would need to do is with each step, we would need to store the ID of the tutorial that that step belongs to. So we always have to put the foreign key on the many side of the relationship in a one-to-many relationship. Okay. In many-to-many relationships, You hopefully remember that they cannot technically exist in a relational database. There's no actual way to set them up. So essentially, many-to-many relationships, theoretical many-to-many relationships, are always simulated through the use of several to one-to-many relationships. So here, for example, the relationship between a semester and courses. Right? If you think of a course as being a particular type of class, like Rails class, right? Well, Rails class is something that happens more than one time. Rails classes this semester, I've had Rails classes previous semesters. So essentially, a course can be taught many semesters. Right? In a given semester, there's of course also more than one course that's taught. Right? This semester, teaching Rails, teaching PHP, teaching JavaScript. Right? So we have a many-to-many relationship there. A semester can have many courses, and a course can be taught many different semesters. So in that kind of situation, the way we always have to model it in the database is with a linking table, a table that's put between the two involved in the many-to-many relationship that breaks up that many-to-many into one-to-manys, right? In this case, I've stuck another linking table between those two, and I've called it sections. Think of a section as being an instance of a course. Rails, right? The course is kind of a batch of labs and materials and policies and an idea of what needs to be taught, right? But a group of people all meeting specifically to be taught Rails is not the Rails course, that is a Rails section, one individual instance of the course, right? I always think of courses as being like classes and sections being like instances. Of course, my brain is completely polluted with object-oriented stuff, so what can you do, right? So anyway, with my sections table stuck in there, essentially what I would say is that I would say that a semester can have many sections, but every section belongs to one specific semester. Right? A course can have many sections of it taught, but each section that's taught is always of one specific course. So with that put in there, we've dissolved the many-to-many relationship, essentially, into two one-to-many relationships. At which point, when the foreign keys come in, we just follow the same rules we typically follow with one-to-many relationships. The foreign keys have to go to the many side of the relationship. So we would take the ID of a semester and put it in the section table as a foreign key. We would take an ID of a course and put it into the section table as a foreign key. So our section table would have the ID of the semester it belongs to and the ID of the course that it is a part of, right? Along with any other details about that individual section. Is this all familiar? Good. In Rails, right, it's important that we remember all these fundamentals, right? Because we have to communicate with Rails in the proper way, depending on whether we're talking about one-to-one, one-to-many, many-to-many, which side of the relationship we're working on, right? None of this goes away. None of it, right? It's all still there lurking beneath the surface. But right, ActiveRecord does a splendid job of taking care of a lot of the lower level details for us. Like, where does the foreign key go? Right? Well, for the most part, Rails ActiveRecord knows where the foreign key goes, right? And we'll just expect it to always be there. Right? So we don't have to go around constantly saying, this is where you find the foreign key. ActiveRecord just knows where the foreign key is. Right? So it does a good job of hiding away a lot of the implementation details of relationships in relational databases for us. Right? So it seems far less complicated, but that's really just on the surface. You always have to keep in mind what's actually happening. Otherwise, you can very quickly get lost in what ActiveRecord is actually doing for you. Right? A big part of the magic, big part of the way that ActiveRecord is able to do this, right, is that it, like we talked about back on the first day, favors convention over configuration. Right? Basically, ActiveRecord makes assumptions. One of the assumptions that it makes is that every record in every table, no exceptions, right? Every record in every table will have a field called ID, right? And that will always be the primary key of a table, never anything else, right? In my opinion, that's a pretty good way to go anyway. Even when I'm not using Rails, I still set things up exactly that way. There are lots of other ways you could put together an ID, but almost every other scheme for putting together an ID other than just some seemingly unrelated number, right, tends to fall apart at one point or another. So the ways Rails does it is, I think, generally a best practice anyhow. So the fact that it assumes that it's going to be done is fine. I have absolutely no issue with that. Okay. The other thing it always assumes is that it will be able to construct the name of a foreign key field. Right? If we have a relationship, say, between tutorials and steps, right? A one-to-many relationship between tutorials and steps, what Rails would automatically assume is that the foreign key, of course, is on the many side of the relationship, so it should be able to find a foreign key in the steps table, right? And it will assume that that foreign key column name is the pluralized form, no, I'm sorry, the singular form of the table that it is representing. So if it's tutorials related to steps in the steps table, Rails would assume it would find a foreign key field called tutorial_ID. It automatically synthesizes that name and expects to find it and use it. Right? So those two basic conventions, always having a primary key called ID, always having a foreign key that's the singular form of the related table's name followed by _ID, right? With those two pieces of information, ActiveRecord can make some very intelligent guesses and figure a lot of things out for us without us having to do a lot of the legwork to get all of this set up and put together. All we have is some very, very simple little bits that we have to throw in order to make all of this relationship stuff work. Right? Not only work in a database sense, but work in an active model sense too, where not only will the correct things happen in the database, but the actual Ruby objects that we're dealing with, the ActiveRecord objects, will automatically be in on the entire scheme and will be able to work and act together just like the database tables will, behind the scenes. It's a pretty cool setup, really. Okay. One last thing I might mention before we start digging into this is that all of that convention stuff, right? Tables, or every record has to have an ID column. Foreign keys are always named this particular way. All of that can be overridden, right? It is possible to override it, to basically not do things the Rails way. So if you ever run into a situation where, say you have a legacy database, a database from some other application, and you want to write a Rails app to work with it, right? That can be made to work. Rails can be made to work with a database that doesn't follow these Rails-specific rules. It does complicate things. There will be a lot of extra work that will have to take place on your part, getting everything configured and set up. The beauty, though, is that if we aren't having to deal with one of those sort of edge case situations, like a legacy database, right, then everything stays real simple. Go figure. Things get more complicated when they get more complicated. Yeah. All right. Let me leave this tutorial thing alone for right now. I'm going to get back out of the console. I want to start a new project. Let's do a Rails new relationship example. That's what I'm going to call it. There we go. I'm going to jump over to that directory. I'm going to go ahead and open it up in my editor. And I'm going to go ahead and edit my gem file before I forget. Group development do gem HIRB gem awesome print. Just like we did a minute ago in the other one. Back over on the console, I'm just going to run the bundle command. Shouldn't take long because those gems are already installed, already available. Okay. All right, so what I want to do is I basically want to go through and I want to play with the three different types of relationships so that we can see how to construct them in Rails and then how they react on the model side. So let's start off by just putting up a one-to-one relationship. Let's do employee office. Right? If we're going to set up employee office as a one-to-one relationship, we're going to need to create those models and the associated database tables, of course, right? So I'm going to say Rails G model, Rails generate a new model. I'm going to call it employee. And let's say every employee has a first name and a last name. Not specifying data types, so those will both be strings. There we go. I could go ahead and migrate my database right now, but I don't really need to quite yet. I'm getting ready to do another one. Besides the employee table, I also need an office table. So I'm going to say Rails generate a new model called office. Let's say that every office has an office number, which I'm just going to leave as a string. It's not like I'm doing math on it. Let's say that every office has a building identifier, which I'll also make a string. Say every office has a size. Right. Everything normal so far, just regular old fields to go along with an office, but here's something special. When I create my office table, I'm also going to put in employee colon references. You can read that as an employee that this office references. Basically, the employee that this office is connected to. Right? By putting in employee colon references there, what I'm essentially doing is I'm letting ActiveRecord know that we are going to need a foreign key field here in the office table. Right? I could have created it manually. I could have said create a field called employee underscore ID and make it an integer. That's basically what it ends up being. Okay? But by using the Rails specific notation here, saying that there's an employee that is going to be referenced, it'll actually do that and take one additional step for me that I'll show you here in just 1 second. Okay? I'll go ahead and hit the enter key. There we go. And while I'm here on the console, let me also go ahead and do rake db :migrate to apply all that to the database. So it creates my employee table, it creates my office table.
When you added HIRB and also print, what did you run after that bundle?
Bundle, yes, just bundle. Now, before we dig into this, just to go take a peek real quick, if I go look at the migrations that were created for me, the employee migration is just as straightforward as can be, just creating 2 fields in a new table. When I look at the offices table, you notice how it put in the employee, that there's an employee that we're going to reference. Okay? It'll automatically turn that into basically a integer field, right, with the appropriate name. Okay. It also automatically added the employee ID, which is going to be the name of that integer field that's created there, as an index, right, which basically means we'll be able to search efficiently based on what employee an office belongs to. Okay. Let's take a look at the model files. If I look at the employee model file, everything's there basically like it's always been. If we take a look at the office file, the office model file, we've got something new there. We've got this line belongs to employee. That's basically what that references bought us. I said that we could have just manually created a field for the database called employee underscore ID and made it an integer. That would have worked fine, but by us specifically doing it the Rails way, using that references notation, Rails understood that, right, as meaning that this office was going to belong to an employee, so it automatically added this line to the office model for me. Right? What that line is actually going to do is on the office side of the relationship, it's going to allow us from an office object to be able to immediately access the employee that that office belongs to. So through the objects, we'll be able to jump straight from an office to an employee because it understands at the object level about the relationship between the two. Excuse me. Okay? Kind of the trick, though, right, is that one of these two had to be created first, right? We had to create one or the other first and then create the other one after. So I created employee first and then I created office, right? If I had done it the other way, right, then I could have over on the office or on the employee side have it say belongs to an office, right? Although that's a little insulting to the employee, isn't it? Your job is to occupy this office, right? One way or another, right, there's no way for us to kind of build this relationship from both sides automatically, because at the time the employee was created, the office didn't exist yet, so there was no way to know what the relationship was supposed to be automatically at that point. So what we have to do is over on the employee side, we have to do a little bit of manual work, right? Just like over on the office side, it says that the office belongs to an employee. We need to, over on the employee side, make the employee class aware of the fact that an employee has an office. It's highly complex how we have to do this, right? The process of specifying that an employee has an office is tough. You ready? We say, has one office. See, wasn't that hard? Not really. Okay? What these two things are going to do, the belongs to employee in the office class and the has one office in the employee class, is at the object level, it's basically going to add a batch of new methods to each of those classes. Okay? For example, an employee object will gain an office method that when we call it, will trigger a database lookup that will return to us in object form the office that that employee is related to. Okay? Over on the office side, the belongs to employee, okay, will again add some custom methods to the office object. So when we have an office object, we'll be able to say office.employee, an employee method, and it will automatically trigger a database lookup and return to us in object form the employee that that office is used by. Uses? The employee that that office... How do you describe that? The employee that that office what? Is occupied by? There you go, is occupied by. Okay? If you ever find yourself trying to call what's probably going to very quickly become kind of a standardized method idea to you and that says the method doesn't exist, always come back and look and make sure that the relationship is specified on both sides in the model files. Okay. It's also not an issue yet, but I would encourage you to strongly also start paying attention to pluralization. Right? In this case, right, both of these two methods, when they are called, are passed a symbol, and both of the symbols are in their singular form. So an office belongs to an employee, specifically just one. An employee has one office, just one, singular. Right? You'd be surprised how sensitive things are in Rails, especially in this relationship stuff, to pluralization. Okay? It expects for names to always be given in the proper pluralized form or unpluralized form. And if you get it backwards, if you mess it up, things can get pretty haywire. I have to say that one of the biggest struggles I had when I first started learning Rails was fighting with the pluralization, because I had always come from programmer mind way of doing things, where a name was a name was a name, right? If the database table was employees, then every time I talk about that database table, I should say employees, right? But that's not how it is in Rails. It wants to be natural. It wants to be language-like, right? It wouldn't make as much sense to say office belongs to employees when in actual fact it only belongs to one. That would be, in Rails terms, considered to be incorrect and accurate.
Rails uses common sense.
Yeah, and that's what killed me. was in programming, I was not at all used to using common sense, common language. I wanted to use nonsense language, like you usually do when you program. Right? And it took me a while to get used to it. Nowadays, whenever I'm in doubt, if I'm not sure, should I pluralize this, should I not, I always say it out loud. And whatever sounds better out loud, whatever makes more sense in the way it's said, that's the one I go with, and that's usually the right one. Okay? So let's see what we've got. Let me jump over to the console. Got just enough time here, hopefully, to play with this a little bit. Yeah. Let's start by creating a couple of different employees in a couple of different offices, and then we can start hooking them together. All right? Let's start by making an employee. Let me say BMW is a new employee. Actually, I'm going to do employee.create just because it's faster. I'll say that the employee's first name. First is one of my first graders' spelling words this week. She keeps getting it wrong, and I think I just mistyped it every single way that she's gotten it wrong this week. Bernard. Last name. Rangel. So there's my new employee. Bernard Rangel, saved in the variable BMW. Now this is cool. If I go to my employee, BMW, and I say .office, it comes back and it gives me nil. Why? Well, because BMW has not been assigned to an office. But look at the SQL. Right? When I asked for BMW's office, it was able to construct an SQL query where it actually went out to the offices table, right, and tried to find an office record over towards the right end where the employee ID was the ID of this employee. It was automatically able to figure out the field name, the table name, the ID that was supposed to be used, all from me just saying .office, just calling an office method. It inferred all of that information, was able to construct an SQL query and determine this employee has no office right now. Okay? So let's give them an office. I'm going to make an office, I'm just going to call it 1. So 1 equals office.create. I'm going to say it's in the SAC building. I'll say it is office number 321. And I'll say the office's size is large. There my new office has been created. You might notice in the output for the office, there's our foreign key field, employee ID, that was put in when we asked to have the model reference an employee when we created it. Okay. If I go to my new office and I call the employee method, it comes back and tells me nil. Right? Because currently that employee or that office has no employee assigned to it. Right? Didn't see any SQL executed. Somehow it knew without actually having to touch the database that there was no employee there yet. Okay. All right. If we were working purely with the database, what we would have to do if we wanted to put BMW into Office 1, right, is we would have to retrieve the ID of we'd have to retrieve the ID of BMW, the employee, and then we would have to insert that ID into the employee ID field of Office 1, right? Here, what we can do is we can say BMW.office equals 1. I hit enter. And basically ActiveRecord does all that work for me. It actually went out and updated the offices table where it set the foreign key field employee ID to 1, which was the ID of that particular employee. And it did that for the one office that we were assigning to that employee. So that's a lot easier, isn't it? bmw.office equals 1. It's just like working with objects, simple. Right? But it's completely mirroring everything we are doing in the background in the database. Okay? If I go to BMW now, and I say .office, it now says this is the office that goes with that employee, and that is the right office. 321 in the SAC building, which is a large office. If I go to Office 1 and I ask who its employee is, 1.employee, it comes back and it correctly tells me the employee that's assigned to that office is Bernard Rangel, BMW. So the relationship is there, it's recognized, and we're able to make use of it through pure object-oriented type notation without having to do any special SQL ourselves. Not too bad, huh? Can you see how somebody who didn't even understand relational databases could potentially get started working with this? Right? It also, though, unfortunately, doesn't take long where if you don't understand relational databases, you dig into this and you very quickly get lost and stuck and messed up. It really does help to understand what's actually going on under the hood. Even if you can't necessarily write every bit of the SQL yourself, just the general concept of everything is important to understand. All right. Some other interesting things we can do. If I wanted to know specifically the office number for the BMW employee, if I say bmw.office.number, right, I retrieve the number from the office for that particular employee, just like if I had said 1.number. Right? It understands that the office for that employee is office 1. If I go to the office 1 and I say, what is your employee's first name? I get back Bernard, just like if I had gone to bmw.firstname. Right? Pretty smart, isn't it? You can build up some very interesting chains of relationships. Right? To me, the way that ActiveRecord does this is the way that I think relational databases should have always done it. When you think about the concept, the design of a relational database, where you should be able to so easily jump from one table to the next table to the next table to the next table, following these primary foreign key relationships in order to drill out particular pieces of information you're looking for. It's a beautiful concept. Unfortunately, in SQL, it never really comes out to be all that elegant. It ends up being these huge, gnarly, awful-looking SQL statements, right? Matching this ID versus that ID, finding your way from table to table to table. But ActiveRecord, I think, really sort of fulfills a lot of that initial promise that I always thought was there in relational databases. Sort of a beauty, sort of an elegance to it. I should put on my geek glasses, shouldn't I? Whenever I start talking about elegance, it's time to pull out the glasses with the tape on them. Yeah. Okay. So in this particular case, what we had done was we had created an employee, then separately we had created an office, and then after the fact we had put the two of them together. Okay. There's also the possibility that we could actually create an office based on an existing employee, or we could create an employee built on an existing office. Right? We could actually use one or the other to aid in the creation of the other half of the relationship. Right? As an example, let me make another employee. Let's do PB is a new employee. I'm going to create first name of Purdy. last name of bird feeder. So now I have a new employee. I've got Purdy bird feeder stored in a variable PB where I can reference them. And of course, at that point, if I say pb.office, I get back nil because I have not given PB an office yet. PB does not yet have an office. If I wanted to create an office specifically for PB, right, not just a general office on its own that may be assigned to PB later, but if I had a new office to put into the system right now, and that office was being put in specifically so that it could be the office of PB, what I could essentially do is I could take the two-step process of 1, create the office, 2, assign it to PB. I could turn that into just a one-step process, create an office for PB. Right? The way I could do that is by using a build method. Right? Another one of those special methods that gets added for us when we set up the relationships between our two tables is we get a build method. So if I say pb.build.office, right, it's basically like calling office.new, right, creating a new instance of an office. Except when it does office.new, what it will do for me is it will automatically fill in the employee ID for the employee where we're calling build. So this new office that's being created will already have PB's employee ID filled in as the employee that this office belongs to. Right? I can just go ahead and fill in the rest of the information. I'll say the building is the SAC building again. Let's say the number is, I don't know, 444. I don't know why I'm thinking about it so hard. It doesn't especially matter. Let's say the size is small. I hit enter. Oops, no build method. Oh, I did it wrong. It's not a build method dot office, it's build underscore office. A new method called build underscore office. There it is. Underscore, not dot. There, that did it. Okay. Now, I mentioned that when we call this method, this build method, it's like calling new, like creating an office with new. And you remember when we created a new ActiveRecord object with new, basically the object was created in memory, but had not actually been committed to the database. Same thing happens here. When it shows us this new office, right, notice that it doesn't have an ID, doesn't have values for created at and updated at yet. Right? That's because it has not actually been committed to the database, hasn't actually been saved. It does, though, automatically have the ID of the employee in it. Right? That's what the build got us. Okay? At this point, if I go to the employee, PB, and I call save, so I'm not saying save the office, I'm saying save the employee. Right? When I hit enter, what it actually saves is both. If there were changes to the employee, which there weren't, the employee would have been saved. But when I called save on the employee, it recognized that there was an associated unsaved object, an associated unsaved relation in the form of that office. So it went ahead and saved the office. Kind of cascading through the tree of relationships, making sure that everything associated with the object that I said save with was saved. If I then say pb.office, there is PB's office. If I take a look at all the offices, office.all, there are both of the offices that have been created and the employees they belong to. If I say office, find the office that has an ID of 2, and give me the employee's last name, I get back bird feeder. Pretty smart. Okay. So what have we done so far? We can create an employee, we can create an office, individual and separate from one another. If we want to, we can then take those employees and offices and we can assign them to one another, right? So they become connected, they become related. Right? If we start off with the intention of wanting to have the two related to one another, we can create an employee and then call build office to make them an office and then save the whole thing. Right? Or we could have created an office, and from the office we could have called build employee, and we could have built an employee specifically for an office. Works either way. Okay? There's also a method called create. Right? Create office or create employee. Right? For example, if I were to make another office, let me make an office called 3. Right? Office.create. Building science number is 987 and size is large. I now have a new office that's saved in a variable called 3. Right? That office currently has no employee. If I say 3.employee, nil is what I get back. Right? No employee assigned to that office. If I want there to be an employee in that office, if I did 3.create employee, the employee's first name could be Victrola. Last name could be Firecracker. I hit enter. And we've created a new employee for that office. Now, unlike when we called build, notice that the new employee here has an ID created at and updated at. That's because when you call create something, it automatically saves. Whereas when you call build something, it's like calling new. It doesn't automatically save. Right? The fact that I did it from the other side of the relationship is really sort of irrelevant. Right? The difference between build something and save and create something is build does not automatically save. You have to save manually. Create automatically saves. So if I go to Office 3 and I say, who is your employee? Okay. It comes back and tells me Victrola Firecracker. Okay. If I take a look at Office 3, it automatically put that employee's ID in there. I didn't have to do that manually. I didn't have to say, assign this employee to that office or that office to this employee. The fact that through the office I called create employee, that implied to ActiveRecord that the two were supposed to be connected, so it handled putting in the correct ID number to make sure that they would be in the database. Not too bad, huh?
Which do you use more, build or create?
Build, usually. From the controller, why do I usually use build? Instead of create. You know, off the top of my head, other than just because that's the way I've seen other people do it more, I can't give you a good answer. I should be able to tell you more specifically why, but build was kind of the way I initially learned, and I think I always just kind of fall back to that. And where I initially learned was usually by reading stuff that other people had written. Build was what I always saw used. So why not use create? I don't know. Could, probably. I have to remember that later. See if we can suss out some difference, why one might be better than the other.
Does not saving have a benefit over saving?
I was trying to think if maybe choosing the time and place to save might have a benefit of over just having it just happen. You know, being able to say, go ahead and build it now, but it isn't until this point that I want to trigger the save and figure out is it going to work or not. Because just like with our sort of single-dimensional models, if you want to think of them this way, the things we were playing with before we started playing with relations, what would happen is if we have validations in here, which we currently don't, if the validations fail, right, they'll either fail when we call save, if something was created by using build, right, or they'll fail when we call create, if that's the way we go, because the create implies save. So being able to decide at what point you want to make that go, no-go decision, kind of in a way. Have we passed validation? Are we ready to move on? Or was there a problem and do we need to go back? Being able to choose the exact moment when that happens might be a benefit. But it seems like we could probably, in most situations, still make that work with create. We'll see. All right. That's probably a good place for us to stop today then. We will certainly have a lot more to play with on this front next week. We can keep working with this one-to-one relationship a little bit more, just seeing what else it has to offer, right? And of course, once we get through that, we can go in and we can start playing with one-to-many relationships. And then we will get into the many-to-many relationships, which get a bit more complicated. Always, right? All right. Were there any last questions? Hope you guys have a good rest of your week, good weekend. I'll see you Tuesday. All right.